Now I'd like to talk about mechanistic strategies when dealing with aldehyde and ketone reactions. And I would direct your attention to this particular section in the textbook. It's very important. I want you to read that section, and certainly you can follow along with this video as well. So a few important rules that we want to keep in mind. Generally, under acidic conditions, protonate the carbonyl first. Before nucleophilic attack. So we want to, if we have acid present, we want to make the carbonyl a better electrophile by protonating it first. We want to avoid multiple cations in the same molecule. I'll call it intermediate because typically we don't have a molecule that has a cation. So avoid multiple cations in the same intermediate. So if you're drawing a mechanism and you end up with two cations on the same intermediate, you probably went wrong somewhere. You need to back up a step or two and figure things out. And the leaving group should end up neutral. Don't expel OH minus or OR minus. Protonate first, then expel a neutral leaving group. And under acidic conditions, all reagents, intermediates, leaving groups should be neutral or positive. Let's look at some reactions. We learned the acetal formation reaction. I'm going to actually just use sulfuric acid here. And we pointed out, or tried to point out, that we can go in the reverse reaction too if we add water and acid catalyst again, H2, having trouble drawing here, H2SO4. And the mechanism, we looked at the mechanism for acetal formation a few videos ago. You know how to draw the mechanism for the acetal back to the ketone mechanism. It is simply the exact opposite of the acetal formation mechanism. So look on your notes, write that mechanism in reverse, and you have the hydrolysis mechanism. So this is called hydrolysis. Breaking bonds using water. So we're going to add water. This green pathway produces two R alcohols at the end of the day. In this case, it was ethanol. So we would reform our alcohols, reform the carbonyl. We can look at a couple other reactions. We talked about the imine formation. And we can go in reverse of the imine formation as well. And that again involves acid and water. And that again is a hydrolysis reaction. And you know the mechanism for this. All you have to do is draw the exact reverse of the imine formation mechanism. That's how you get to back to the ketone. So you can already draw this one. And finally, we have the enamine formation. And as you might guess, I'm going to tell you that you already know how to draw the reverse reaction. Again, that is H2O, H2SO4, another hydrolysis reaction. So I have basically 6 mechanisms represented up here. They're all very similar. The blue ones are all very similar. And then the green ones are all the reverse of the blue ones, and they are also very similar. Remember, it's just a bunch of proton transfers and an occasional nucleophilic attack or loss of leaving group. And so you can expect to see one of these 6 or more on an upcoming quiz or exam. So you should be ready to show me any of these mechanisms here. They're all present in your book. You can follow along with the book. You can look at the mechanisms we drew on an earlier video. And you can find some skill builders on these mechanisms as well.